Well, I'll just run it with this. This is some generic diode model. It works. Actually, I changed this. Change this back to make it. Yeah, this thing automatically scales too, so that this is actually the output. Here we have 0 volts, and it goes down to -10 volts because it's amplifying our 1 volt sine wave. And it goes up to 0.652 volts, which is a diode drop for some kind of diode.
Where's the input on that? I'm in the back here.
Where
are your probes?
Go back to that scope trace for just a moment, I appreciate it.
Can you keep your probes shown on your schematics in case you have like 15 probes and you forget where your probes were placed?
It doesn't, but when you see the probe, if you look on this line at the bottom, where there's a bunch of
status indicator.
Yeah. If you put your probe up there and look down there, it says click to plot V in node 002. Oh, and you can, if your plot has several lines like this one does, you can double click this and get only that plot.
You could put a label on it if you put a label there saying that's where I put my probe. So like probe 1 here, you know,
Yeah.
a little label there.
How many probes can you do at a time? Just one or
Oh,
two,
a lot.
three? A lot?
More than you, more than
Whatever
you'll probably
want to.
use.
Yeah.
Okay.
Well,
In fact,
we've only got,
you can even take a probe and put some math between 2 different probes and actually see the math operate on that formula you plug in.
yes, there's somewhere in one of these menus is add trace. And I can just do that. So once you've got a plot and several points, you can do mathematical operations to take the differences and things. Even multiply them to multiply voltage and current. Oh, that's another thing. You go here.
Can you make it draw
Click.
AHRC like Clint did?
Not in a few minutes. But you've also got the current thing. You put this above a component when you are on the schematic and you've got a simulation up, and you see that thing, and that's the current probe, and you click on it, and it adds a current. And it's got IR1,
Oh.
which is scaled to this. It goes from 0.1 to -1 milliamp
Where'd you get the current probe?
by hovering over the
Oh,
component.
just hover over it, right? It automatically does it.
And you can do the diode or just double click to have the diode only. So where was I? I was wanting the voltage here, which is 0.65 volts, and that's some generic diode model. Right click brings up some sort of menu for each component, and this one is, you can do a pick new diode. pt2 is probably a Schottky, I think. If you simulate that,
What's a Schottky?
it's
Certain kind of diode.
it's a special diode that has a low forward voltage drop.
Okay.
And it was, indeed, we had 0.6 volts and now 0.239 volts for a voltage drop. So we can see where it simulates those different parameters. And there's a lot more to it. It can...
Can you, well, you can jack up the frequency a lot, and then beyond the capability of the op amp, and you'll see your limitations also.
Yeah.
I don't know what the frequency might be, the limitation might be for that, though.
Yeah, and that'll also show the capacitance, so the diode, and throw all that in. There's features I haven't used. This can import a Microsoft .wave file and use that as a voltage source. So you can, if you're doing something musically, a tone control or something, you can do that. It'll generate a wave file and you can hear how it actually sounds.
Like a filter.
There's audio output.
Well, a .wave file, it can read and write wave files.
Okay, so it can generate, you feed in a wave file, and it goes through the circuit, then it writes a wave file that comes out.
Yes.
That's cool.
Hey, I just figured out, to do the differential, you click down, hold it, and then move to another trace, and then let go, and it'll give you that well, you see across two components, or two nodes.
Oh, okay. So, what do you say?
Click, left click and hold, and then drag over to another wire, and then release. Okay, you missed it. It'll change, the probe will change color. Click, and you move it over, then it turns red, and then click.
There you go.
There you go. So you see how it shows you a differential, node 2, node 1?
Okay, well, yeah, well, it did work both times.
Yeah.
Okay, it did, okay.
So once you start getting all those traces on there, I wish you could keep the probes in pt2. You were able to do that.
And that could be that differential could be handy if you're dealing with like a strain gauge, something that has two outputs that tie together to give you a sensitive signal, like a load cell or a Wheatstone bridge, where you don't have a ground reference. That's what the differential probe allows you to not have to have that ground reference.
So, question.
Yeah.
When you're doing, obviously, circuit diagramming and analysis with this, how does this relate to something like Eagle, for instance? Can I draw up my diagram in this, understand, okay, this is gonna work the way I want it to do, and then import this into Eagle to do the layout kind of stuff?
You can do it the other way around. I haven't done it, though.
From Eagle 6, you can go into Spice. I don't know if you can do it.
Okay, so
Yeah.
I can design my circuit in Eagle, get it all laid out the way I want, then try simulating it inside of Spice.
Which is kind of
Yes, that's what the little blurb underneath the ULP said, but I never tried it.
But that's kind of backwards. It seems like you want to.
You want
Do
to try
you-
the circuit
you want to try it before you
lay
build
it
it.
out, yeah.
Go both ways. Be bi-directional.
Oh, you can?
See if I,
Okay. Have you
That
done
would
it?
make more sense.
I haven't done it.
Okay.
I've watched the video slow.
Well, I'll tell you the truth, with Spice Model, a lot of times you want to do things in smaller portions of your circuit. Try to break your circuit into logical steps.
Right.
And do your initial Spice modeling step by step, instead of trying just to do an entire circuit and then see it, because it's just a lot to consume.
Right.
Yeah, it
Baby
keeps-
steps.
Yes. And with a lot of analog stuff, it makes sense. I mean, it's a linear progression,
Right.
change, change, change. It makes a lot of sense.
Can you do anything with motor models, with EMI modeling and inductive kickback modeling? With if you don't have a diode across like a coil, like if you drop a coil out and you don't have a diode, will it show things on relays?
Yes, it can show some of that, but be aware that with Spice modeling, it's imperfect. It'll give you its best estimate on what it should do, but theoretical the Spice has versus the real world are different, because there's more parasitics in a real circuit than there is in a Spice model.
but,
It'll
well,
give
if
you
you
an
can
idea.
measure the parasitics, you can add it as various, inductors and capacitors in the model and get,
Right, okay.
you know, as
Spice
accurate
modeling's
as
a
you
good
can
best
know
guess.
what the, if you know what the real model is, you can get just as accurate as to your knowledge in SPICE.
Well, I've seen in turn-on situations and circuits, if you're trying to model that it might get kind of close, but the frequencies you see, the durations you see, it's not going to match up identical to the real world. You know, it's a good guess, but our
Well,
SPICE,
it's as good as you can measure to the real world. That's
no.
just-
I mean, my SPICE modeling teacher told us, look, use this as a reference, but don't consider this absolute law on how the circuit's going to work. She literally said, SPICE, even a change in models, the same component, can make a difference on how this.
Okay, but
goes.
that's,
That's high end though, I agree.
well, that's, how close the model is.
Yes, that's right.
That's
And
dependent
how
on
close your model fits what you're trying to test.
Well, let's let Ben continue.
Sure.
Well, it's, and well, op amps can be pretty far off, but resistors, capacitors, and inductors are these are 100% the theoretical values. And if you want to add a series resistance, you can,
Mhm.
or you parallel resistance and capacitance and things like that without physically adding without physically adding a resistor in series. You can do that.
I think what Lynn's getting at is that high frequency stuff, for example, if you're doing this stuff at 900 megahertz or whatever, capacitance between two wires an inch apart are gonna make a difference. How do you know what that is? It's hard to model it in that if you don't even have a clue as to what.
Yeah, I guess, and that's. I know on circuit boards there's ways to calculate that capacitance
Yeah.
to some approximation,
Yeah.
and at least
In
put
the real
that
world,
in.
it's hard to get every single variable pinned down.
Yeah. So where else was I going to go?
See, just,
Seemed to fit. Yeah, I saved this webpage, but I didn't get the,
I presume that
Figures.
for the voltage sources, there's all sorts of square wave, triangle wave, and all that kind of stuff.
yes.
Right there.
You
is
can
that
hit
also a
fun-
sawtooth, the SFFM?
Yeah, you can put function none, and then
You can get pretty fancy. They have
At a
piece
value
lines
of
where you
1
can
volt.
actually piece segments of voltages together in a ramp and go from one voltage to another.
Well, I can
Oh,
see
I
where
think
this
that's
would even
what to
be
do.
handy, just, you know, building my little Bobot circuits.
Oh, yeah.
there's
Especially if
other
you're trying to use the
simulations.
frequencies, like for remote control or something, it'd be a great way to simulate it.
It does really well for very small circuits. I mean, you don't have as much that can vary the smaller the circuit.
This you can do like a frequency response graph. And it puts a semicolon here to know that it's not going to do that simulation, it's going to do this one. And I believe it comes up with an error. Yeah. Huh.
You get your L1 left out hanging.
Oh, okay. And there was another error message about this thing needs to be,
Oh, you're trying, you have a DC
Yeah.
source?
set the value to a current or voltage source to AC1.
Is that the AC you just added in there, the dot AC?
No, that's the simulation plan, it's a different thing.
Okay.
But that is now something that tells the simulator that that's the source that's going to vary the frequency with. And I guess it just did it, and that shows what this thing is. Let me get rid of the diode.
And how do you have two signals going through that?
Oh, that is, one is frequency,
One's phase, right?
yeah, the other is,
It's AC, and AC has phase, so it
Yeah.
shows the phase.
you see on the right 180 degrees. It's an inverter, so the phase is 180 degrees, but as it hits the high end of its frequency response, the phase changes too as the frequency goes down, as the gain goes down. And this shows frequency in hertz, magnitude in dB is 19 dB above the input. I can change the value of this to 1K to make it a gain of 1. Simulate it again, and yeah, these windows can change positions, but where am I? There it is. The gain is 0 dB until we get way up here at the end of the wrong thing. There it is. Gee, this doesn't look right.
Is it dB decibels?
Yes. I don't know what it's doing here. I look at that. I look at this. It's showing it down here, but the trace is up here.
Looks like
That may be
V is at 0 decibels.
Yeah,
No
well,
2.
gosh, I don't know what's going on with this. But
Now, if you click on phase in that window right there, if you click on phase instead of magnitude, is that going to, is your blue line your phase?
yes.
There you go.
And that shows the phase over here. I don't know why it's at minus 36 dB or whatever. And,
Well, is that minutes? Is that phase? Is that,
degrees and,
Magnitude?
well, it's a full circle.
Phase.
I would-
that's,
360 minutes, is that a full circle?
I don't know what, that should be degrees.
Your magnitude isn't changing.
Yeah, but it's minus 37, it's down here.
Yeah, so that's the horizontal blue line.
So radians maybe?
That would make more sense if it was an R.
Now, do they have different views for it?
Oh, there it is.
What do you
Still
mean different
nice.
views?
They do because they're very small.
Well, because you were saying it was 360 degrees, so I was wondering if you could,
Well, that's the scale. It goes from 0 to 360.
Yeah, you're
And
seeing
for a
the-
circle.
You're seeing two scales there. You're seeing on the left an amplitude
Wait a
scale, on the
minute.
right is a phase shift, I believe.
I see what happened here. This,
Denise, did you get that?
No. I don't think I'm gonna get it today either. It's okay.
I'll post the video.
If you want to demo that, you should put a capacitor across all one, that'll give you a phase shift.
that is what happened.
Oh.
This got deleted for some reason.
Do you have to rerun it, or did you just do that?
I just did,
Okay.
I think. Yes, we are at 24 micro dB. Looking right up here, it's,
You're following the phase
Nice.
curve right now.
well, yeah, okay, well, I'm reading the magnitude, which is 3 dB and 26 kilohertz. And this goes down 21 dB. Yeah, this is working now. So, well, I guess that's what I have. Does anyone have more questions or comments?
You can use this to, if you know the basics of op amps and transistors, to really learn configurations more without breadboarding all these different types of things. Just
Oh, yeah.
click and simulate and get a lot more done in an hour to learn.
Very cool.
And it's free.
Yeah.
Yay, free.
It's a very fast download too. It's a very lightweight program. It's not a big pig.
I remember, Spice itself was originally written on, fax systems back in the early 80s, late 70s. And
But nobody's bothered to weight it down with.
Exactly.
With Java and
This
all that
user,
stuff.
this user interface is by far the heaviest piece of the
I was
system.
gonna say, they need to change it to the new ribbon style interface.
Yeah, right. Yeah.
Well, actually, probably when it was developed, they were probably using punch cards.
Yeah, I mean, it's
Berkeley worked on this
Wow.
back in the 60s, was it?
70s.
I'm sure it's in the x86 folder, not the
Yeah.
64-bit
Yeah,
program
I'm
files
sure it is.
folder.
Yeah. I mean, I did some downloading of the original Spice from Berkeley